Welcome, everyone. I'm David Craig, co-chair of the Task Force on Nature-Related Financial Disclosures, and I've spent many years working in financial markets, technology, data, and sustainability. And today, we're going to talk about the Land Sector and Removal Standard, otherwise known as the LSRS. This is a new international framework for reporting carbon removals on land, and it sits alongside the emissions rules that we all know. But it also opens up a big opportunity for companies and investors, especially those involved or investing or dependent on agricultural supply chains. They can now understand and manage carbon drawdown and supply chain resilience in a much more rigorous way. So to discuss this opportunity, I'm joined today by Professor Jacqueline McGlade. Jackie, founder of Downforce Technologies, has had a remarkable career at the intersection of science, policy, and Earth observation. She served as chief scientist at the United Nations Environment Programme, led the European Environment Agency, and has spent many years working on issues that are now central to LSRS. So Jackie, thank you very much for being here.
Thanks, David, very much. It's a great pleasure to be here with you, answering questions and hopefully putting some insight behind some of the words that are very, very tough when it comes to reading what we're going to be doing. So a lot of my work at the UN and in the European Environment Agency was really about how we could make environmental data scientifically robust, traceable, and also grounded in physical reality. And most importantly, collecting the data once and using it many times, making it really efficient. And what that really comes down to is gathering data that helps us understand the natural variability, yet dealing with uncertainty as honestly and transparently as we can, and to make sure that wherever we use models, they're calibrated with empirical measurements and they're not just simply assumptions. So there are a lot of principles that sit inside the standard that are very important. And they really lodge on several ideas. One is having empirical baselines. Another one is about the calibration, at least every 5 years. Traceability back to the land unit, that could be a field or a larger area. And then the transparency of the uncertainty that actually lies within the numbers. And this is exactly what the new standard brings together. And it brings it together in one clear global standard. So I'm really delighted to be able to unpack that with you today.
So let's start right at the beginning. What do we mean by removals, and what exactly is the Land Sector and Removal Standard?
Well, that's actually the best place to start, which is around removals, is in the title. And what we actually mean is taking carbon dioxide physically out of the atmosphere and putting it into the land in a land-based carbon pool. And it's usually as a result of land management practices. So when that carbon goes into the land, it can be stored as soil organic carbon, but it can also be in what we know as above and below ground biomass. So trees in the roots, in the trunk and in the leaves. It can also be the crop itself. Or it can be what's called dead organic matter. So this is the material that once was part of a living organism, but is no longer alive. So that can be the remains of plants and animals and their waste products. So the Land Sector and Removal Standard is the Greenhouse Gas Protocol standard for how companies report emissions and carbon removals on land. That's in soils, forest, grasslands, and in biomass. And what it's asking companies to do is to measure that carbon stock change in the pools that are identified and to report them separately from emissions. So there's no netting off, as we would call it, one against the other. It's really looking at the emissions and the removals. So for the first time, then, we have the other side of the balance sheet, the other side of the ledger, and that now becomes visible and, of course, auditable.
So the second question is, I guess, Jackie, why should companies care about this? What's the business case for doing this?
There are 3 big reasons why companies should really care about the standard. The first is supply chain resilience, the second is credibility, and the third is about unlocking those positive contributions. So let's think about supply chain resilience. What I'm going to talk about starts with soils. It underpins the agricultural supply chain, and everyone then in the supply chain needs to understand what is happening to the soil that they depend on, because it connects directly to the physicality and of the supply risks themselves. So soil health is really critical to dealing with drought, floods, and higher temperatures. But as soil health deteriorates, obviously, most of us know that production is going to decline and supply chains are going to be put at risk. They're going to be more vulnerable to disruption and then to price shocks. But conversely, the better the soil health, that's going to help the whole supply chain to be more resilient and in the end to be more dependable. The second issue is around credibility. So what the standard does, by being a global standard for how land-based removals are measured, it really means that if you want to put removals to be recognized by the auditors or the regulators, then through the supply chains, this is the framework for you. This is the standard whereby we're going to be able to keep track of those absolute removals. And thirdly, unlocking positive contributions. So if a company has been improving land practices for a number of years, the standard then gives them a way to measure and report even on those historical gains in a very rigorous way. In other words, it brings all those past improvements into the climate account.
So that's pretty fundamental. It looks like this is quite new and that it's going to bring some pretty big step changes. Is that correct?
Yes, I mean, many people who've been working on this for years have envisaged this day arriving, but I think because it brings so much together, even those who are relatively well prepared need to really think carefully about the shifts. So there are three major shifts. So in the world of reporting, we've got used to some shorthands, and the first one that comes out of the box is the kinds of methods that we use. So we have something called Tier 1, Tier 2, Tier 3. So for a number of years, we've been able to use Tier 1. It's a very basic method. It just uses default activity data and parameters, very suitable where you've got countries with limited availability for data. Then we have Tier 2. This is an intermediate method. It's important. It does require good quality, country-specific activity data on both current and historical uses, and it's suitable for countries with moderate data availability. And then Tier 3. Tier 3 is the advanced methods using local activity. So in other words, we're really getting down to the local sourcing, the emission factors, and what's happening there. Now, these tiers have helped in the past and up until now to make sure that the greenhouse gas inventories are accurate and that the uncertainties are reduced as much as possible. But the new standard says that Tier 1 global defaults are not acceptable for removals. That's very important. So if we want to do removals, we have to ratchet up our ability and the methods that we use. And so we use now Tier 2 and Tier 3. These are the expectations for removals. This is because companies must use site-specific, empirically calibrated data, either from measurement or from model or from remote sensing-based approaches, but they have to be calibrated with real soil data. So that's the first shift. The second one revolves around physical traceability. So you've got to be able to point to the specific fields or the land management unit that you've defined, could be a river catchment, for example, or a region where carbon is being stored and or emitted. And so for a company preparing its greenhouse gas annual report, they will have different kinds of emissions. And I'm sure these are familiar with some of our listeners, but Scope 1, these are the direct emissions coming from sources that are actually owned or controlled by the company. That's fuel, your vehicles, and so on. The Scope 2, which you would have been reporting on, those are the ones coming from the purchase of electricity or cooling or heating, usually off-site, but for which the company is also responsible. And now we have Scope 3, and this is where the traceability comes in. So the Scope 3 is really, again, about indirect emissions, but it's also where the removals that occur in the company's value chain actually can be pinpointed. Whether that's taking crops off the land, extraction of materials, even the storage through the regenerative practices, the negative emissions, this is where they get reported as the Scope 3 emissions. The third point is about recognizing variability. We all know that there is natural variability in carbon sequestration. That's because of seasons, because of weather, and so on. But for the first time, the standard requires this numerical uncertainty to be recognized. So we have to provide confidence intervals, quantified variability, and companies need to demonstrate that they're being very conservative relative to that uncertainty. So in other words, if there's a large uncertainty, they need to take that into account when they put in what the removals are on the audit sheet. So this is a very important and necessary rising of the bar.
Thanks, Jackie. That's very clear. It's a big shift. I want to go a little bit deeper on what lots of people talk about is improving resilience, and particular in supply chains. How does LSRS change the way that companies can now understand and measure their supply chains?
Well, I think first and foremost, although it's the supply chains, it's the risks associated with them. So what the standard does is it makes soils and land use part of a company's risk system, not just its emission profile. And that's very important because pretty much every company has got a risk and audit committee, and they're going to be looking at those risks, going to be looking at climate change. So now we have to think about how the removals and the potential reversals fit into that setting. Because the way it works is that companies are going to have to map their productive lands and the sourcing regions. They're going to measure the carbon stock over time, and then they're going to maintain some ongoing monitoring. So what they're getting then is more visibility than they've ever had before into the supply chain and whether the supply chain itself is robust or where it's vulnerable. So declines in soil carbon aren't just carbon problems. Of course, they have real meaning for farmers when it comes to water retention, when it comes to yield, and that can directly affect the cost and the resilience. But taking care of where soil carbon is being sequestered is also a way of hedging, in a sense, building up the resilience for some of those shocks that are coming down the line.
Jackie, the standard is technology neutral, but it's very explicit about calibration and sampling. How do new technologies fit into the LSRS?
Well, this is where actually the standard is very modern and very innovative in its outlook, because it realizes that when you write a standard and it's around for a long time, what you can't do is stifle innovation. So it explicitly allows for remote sensing-based approaches, model-based approaches, and hybrid approaches. And that's because there's been such advancements in these fields over the last few years that it would be not very sensible to stifle those. But, and here's the but, they have to be calibrated with empirical measurements, using sampling schemes that are representative of natural and management variability. There's that word again, variability. So in one simple way, we can say that technology is giving us continuity and scale. Sampling gives us calibration and integrity. And the standard requires us to do both.
Thanks, Jackie. Very interesting about how the standard allows for future innovation and the application of modern technology. Going backwards a bit, though, one question people have asked me is can they bring past improvements into LSRS reporting? Can companies use historical data, and how can they use it?
They can. And I think the only sort of warning signal I'd put up there is that if they had already claimed some removals, then it's very clear that you can't sort of double up on that. But let's just assume that someone hasn't been putting removals into their greenhouse gas account or their yearly reporting, then this provides a major advantage, because modern remote sensing goes back many years. In fact, 2017 onwards is one of the big sort of stories around this, that the Sentinel missions, as we call them, have been really operating at a very high standard since then. So in Downforce, for example, we're able to reconstruct soil carbon and those trends from 2017 onwards. What that means is it gives companies a historical baseline against which they can genuinely see any improvements on the kinds of management practices they've been undertaking. This is a big relief, I have to say, for a lot of farmers who somehow have been doing it on the basis of intuition, and the data itself can often reify and prove they've been doing great things. So if you've been improving soil management, the standard allows you to account for those, provided that the uncertainty is quantified and making sure that those data are empirically grounded. So it's almost like you can file for a tax refund on the good work you've already done.
So, Jackie, there are many solutions, many technology solutions out there, a variety of them. Downforce is one of those solutions, but just to help the audience, what does a user get if they come to Downforce into yourself?
Well, the first thing to say, of course, is that we have taken a great deal of care to make sure that the methods and the approaches we use are aligned with the new standard. Now, why is that? Well, we provide primary data outputs for soil carbon stock and carbon stock change. We give spatially explicit mapping. That can be at the field or the farm level, the property level. So that's very important. Again, going back to traceability. These are empirically calibrated models, so we really are consistent with the Tier-3 and the expectations of that high accuracy. We quantify uncertainty for all our estimates, and that appears actually for every year and for every field, if that's what you're looking for. But most critically, we can also reconstruct history. So we can go back and look and see how different management practices have affected soil carbon. What we did was, though, a few years ago, we decided to also bring in some additional verification. And therefore, we went down the route of another standard, the ISO standard, which is aligned also with the Greenhouse Gas Protocol. So these two worlds are now being brought together. There's been a partnership between the two. And so what you'll see that the ISO world, which is very much physically known and understood by a lot of companies for a lot of the other activities they do, these two worlds are coming together, and they will all together help companies provide auditable, physically grounded, traceable data that not only meets the high bar that the standard has set, the new one, but which we are able to see some emerging approaches that are going to take us even further. And Downforce, we're very proud to say, is part of that mix.
Thank you. That's very helpful. There's clearly lots of innovation and technology solutions arriving to make this much more practical and effective for companies. I want to finish on this note of practicality. If I were advising the board, they've heard that LSRS is now released, but what should they do in the next 12 to 18 months?
Okay, three things. It's always things of threes. So first of all, mapping the land that matters. In other words, knowing which crops, regions, and suppliers they're dealing with and how much they depend on soil carbon. So whether you're growing potatoes or wheat or whatever in your supply chain, you need to understand the vulnerabilities that different crops bring. Moving to Tier-3 ready data systems, that's an absolute essential part. So shifting away from generic assumptions towards empirically grounded traceable data, very critical. And then prepare for assurance from day one. Document sampling, calibration, uncertainty, traceability in a way that external auditors can follow. And with those three things, I believe that actually the new standard becomes a strategic advantage rather than a compliance burden. It'll feed into the risk and audit committee, it will feed into the bottom line, and it will also help to anticipate some of the shocks because in a way, building up healthy soils is your insurance for the future.
Yeah, that's really helpful. So clearly there's now an imperative to act, but there's also a standard on which you can act on. And just listening to your explanation, which was incredibly helpful, I thought I'd close with my sort of three takeaways. Firstly, I think LSRS, it seems it introduces the first global standard for land-based removals, requiring Tier-3, as you said, site-specific data, and no netting. I think that was an important takeaway. Secondly, and I think something really important that many, many companies are looking at is it brings supply chain resilience and risk into sharp focus by requiring traceability, monitoring, and also this point about quantified uncertainty because of the variability of removals and soil carbon. And the third, I think possibly the most important, is there are now practical ways to operationalize this using remote measurement, empirical calibration, and historical data. So very, very helpful, Jackie, for these explanations. I'm sure there's lots more questions that people have, but hopefully this gives people a lot more confidence that there's a standard that they can use and act on in a very practical way. And your insights have been incredibly helpful.
Thank you, David.
Thank you, everyone, for listening today. LSRS is here, and it's going to shape how land-based climate action is measured. We hope this call helped you understand what's coming and how you can get ahead of it. Thank you very much for joining.